In this question, we're told that Kayang and Maggie are studying the pattern of rainfall where they live in Herne. Kayang decides to record whether or not it's raining at 6 a.m. for the next 10 days. We're asked to state the name of the sampling technique that Kayang is using. So Kayang has just taken the next 10 days as they appear. This is an opportunity sampling. It was the next 10 days that she had an opportunity to collect a reading. Kayang suggests that the binomial distribution with n equals 10 would be a good model for the number of days in a 10-day period when it is raining at 6 a.m. We're asked to explain why the binomial distribution might not be a good model in this situation. Well, the binomial needs your trials, your observations to be independent. And if she's taken 10 consecutive days, it's unlikely that the amount of rain that they get at 6 a.m. is going to be independent. If we're having a rainy season, if we're having a period of rainy weather, one day compared to the very next day are likely to be dependent on each other. If we're in the middle of summer, nice sunny days, if one day doesn't rain, the next day is also unlikely to rain. So these trials are not independent. Next, we're told that Maggie uses data from the large data set for Herne in 2015. She randomly selects 30 days from the large data set for Herne in 2015 and for each day records the daily total rainfall. Some of her 30 days have TR recorded as the daily total rainfall. Using your knowledge of the large data set, from what you've seen, from those sessions that we've had, we need to state firstly what TR means. Well, TR is an abbreviation of trace. And trace means that there was less than 0.05 millimeters of rain. That's what TR means. We're asked to suggest what Maggie should do with the TR values to clean her data set. Now, lots of people think that she should just get rid of those values, but not with TR. TR lets us know there was very, very little rain. So, it's not an absence of data, it's just that there was so little rain it was hard to measure. If there was so little rain, then it's close to zero. It's almost that we're approximating to zero for each of these TR values. So we are going to use them. This was a day when there was hardly any rain. There seemed to be rain for a split second, and then there was no rain. Next, we're asked to explain what effect our action, our suggested action, is likely to have on the estimate of the mean daily total rainfall. Well, if we've introduced lots of zeros to our calculation for the mean, that means that the mean is going to be reduced. We have increased our n value, but the sum of x never increased. We've added on lots of zeros. So we've got the same size numerator and a much bigger denominator. And I hope we all know that that means we're getting a smaller value. So the value that we get for our estimate of the mean is going to be under the true value. It's going to be an underestimate of the true value. Ever so slightly, but still an underestimate. We're told that Maggie summarized her data in the grouped frequency table shown below. We're asked to use this information to estimate the mean for these 30 days. This should just go straight into your calculator. Midpoints and frequencies go into list 1 and list 2, and we know from there we can use the formula. X bar equals the sum of fx and the sum of f. All three of these values are on your calculator screen. 88 divided by 30 equals 2.933. Next, we're asked to show that the estimated value of S of xx for the daily total rainfall for these 30 days is 411.4, and that's to 1 decimal place. Well, the S of xx can be linked to the standard deviation. We know that one of the formulas for the standard deviation is a little bit more obscure than the others, but is the square root of S of xx over n. This is in your formula book. So rearranging, we can get that sigma squared times n is going to equal S of xx. Sigma squared we can calculate on our calculators. It's on your screen already, the same screen that we saw the mean on. the sum of fx squared minus the sum of f minus the sum of fx over the sum of f squared. We should recognize that formula. We can substitute all of those values from our calculator summary screen in, and we should get an answer of 13.712. This is the variance. This is sigma squared. If we multiply that by n, we're going to get s of xx. All into the calculator, and we get 411.37, which is 411.4 to 1 decimal place. We're then told that Maggie defines an outlier as a value which is more than 3 standard deviations from the mean. State given a reason whether or not there could be any possible outliers in Maggie's data. Well, let's do Maggie's calculation. X bar plus or minus 3 standard deviations. X bar we already calculated to be 2.933, and the standard deviation is the square root of 13.712. This, once again, was on our calculator screen. It's 3.703. So X bar plus or minus 3 standard deviations gets us negative 8.176 and 14.042. Out of those, what conclusion can we make about the outliers? Well, the interval at the top end has values that may be anywhere from 7 up to 15. And if our outlier boundary is 14.042, well, then there might be some outliers above 14.042. So there may well be some outliers in that last interval.